on now. Come on. Okay. 6-2, which we are going to talk about nth root. Now, when we take square roots, I'm going to be honest with you. If you memorize your square roots or your squares all the way up to 20, it will help you out, and I'm going to expect you to do so. Okay, we're going to have a little quiz on it coming up. Okay, so let's go over them really quick. 1 squared is 1, 2 squared is 4, 3 squared is 9. You guys only have to write the ones I guess you don't know. Hopefully, once again, you guys already know how hard. I don't know, I just wrote 8. I bet for the first 10 you guys feel pretty comfy, right? Okay, even with 11, what's 11 squared? 121, 12 squared, 144. I think you should be comfy all the way up to there, really, to be honest. That's where usually everybody got memorized is the 12 times tables, right? Okay, here's the new ones probably. 13 squared, 169. 14 squared. Oh, this is 225, so this is 196. Okay, 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 squared. He's the one that I always struggle with. I want to say it's 381.
361.
61. He's the one that I struggle with. And then 20 squared is 400. Okay? Those are the ones I expect you to know for your squares. Okay? What's going to happen is I'm going to give you a little sheet. Okay? We'll put it down. You guys remember the times table test? Back in like 3rd grade, how you rush through knowing all your times tables? Basically, it'll be that. I'll give you like 3 minutes to do 30 problems. Like 30 little things. Okay? So, then we can also go, we're going to teach you to go backwards as well, like 169 to the 1/2, which we're going to learn about this today, is 13. That means the square root. A half power means the square root, so you should be able to go vice versa as well. Does that make sense? Okay. Anyway, we're now asking you to do your 3s. So notice 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. I had to think about that, and that's as far as I'm asking you to go there. And then on the fourths, 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256, and 5 to the 4th is 625. Okay? That is what I'm asking you to memorize. Notice the reason why I'm asking you to memorize those is that when you do this, you can see them quicker. Okay, because we're going to start taking square roots, and if you know these, then you can see the perfect square roots, the perfect cube roots, the perfect 4th roots, and so forth. Right? It makes it a lot quicker instead of always having to break things down to see what they are. You get what I'm saying by that? I see you guys Wednesday and Friday. We will be doing this on Friday next week. Okay, so you have a week to get this done into your brain. Fair deal? Uh-huh. But I only went up to the 4th and the 5th.
Do we have to memorize like how to do it backwards?
Yes. So like if I wrote 125 to the 1/3, you will know that is 5. I'm going to teach you about the 1/3 today and so forth. Whenever you see a fraction, That's a root. That's a square root. If you ever see that, that's what we're getting into today. Okay? Is everybody there with me? All right. Everybody have it written down what we need to
I
do?
can't read 5 to the 4th or anything.
625.
I like these shirts though, they have the cool design on the inside of the.
This is mine. Okay, so, you know, what does a square root mean? What are we doing on a square root? A number times itself. So once again, 36. That is 6 times 6, right? So therefore, notice there is a little 2 here. You guys understood that was a 2 there? It's never written there before, but that's understood to be a 2 there, right? Just like how if I don't write a power on something, it's understood to be a 1 on it, right? If I don't see a number over a radical, it's understood to be the square root, correct? So when you're looking for square roots, you're looking for groups of 2, correct? Okay, notice I have a group of 2, therefore he gets out. Okay, does that make sense? Okay, when I take a square root, when I'm just doing a square root, notice it's just a number. Like here, what's the difference between y on this guy? What do we do on that? How do we solve him? We take the square root of both sides, right? And x equals plus or minus 6, isn't it? Why don't I do a plus or minus 6 over there? Well, here's the reason. When we just take a square root, like over here where we're just simplifying a square root, it's just a number. But when we have the opportunity to plug things in for x, there was 2 options for this, right? 6 squared got us to 36, as did negative 6 squared, gets you there, right? Okay, so understand, just when I simplify, it's just a number. But when I take a square root, that's when we have to do our plus or minus, okay? Some people always got confused about that. So now, once again, what if I asked you for the cube root of 125? What does a cube root mean? So we're looking for groups of 3, right? So notice that's the reasoning why this would be 5 and 25, 5 and 5, and you have your group of 3 there, huh? Okay, so that's why this would be 5. Now, question. Can this be negative to give us a real answer? No, it can't be, can it? Okay, could this be negative to give us a real answer? Yes. Why? Anybody tell me? Give me a number. Okay, this would come out to be negative 5. If I start with negative 5, what's negative 5 times negative 5? 25. So anytime it's an even power, it'll always be positive, won't it? Okay, because anytime we do anything to an even power, you'll have enough negatives that it'll always come out to be positive. But if I have a positive 25 times a negative 5, now where am I at? Negative 125. So on odds, you might want to write this down, on odd roots, you can have negatives underneath them. Okay, odd roots, you can have negatives within them. Okay, you just got to understand your answer is going to come out negative. Okay, so like this, it's like a square root, I can't have it where it's imaginary numbers, right? Same thing with a 4th root, a 6th root, an 8th root, and any of those, because once again, you're looking for groups of 6, and if you had a number 6 times that had enough evens, that it'd always come out positive. Does that make sense? So that's why even roots can only be positive underneath them. Odd roots can have negatives underneath.
So you want to put y?
No, because it's a real number. Because what is the cube root of negative 125? It is negative 5, because negative 5 times negative 5 is 25, times negative 5 again is negative 125. That is something that happened, right?
So with all negative roots, there's never an imaginary number?
Not on odd roots, no. Okay, does that make sense? Why that happens that way? Yes, no? Okay, so that's important to know, right? Now sometimes we break down other things as well, such as, like when we did square root of 8. Okay, what's in square root of 8? 2 and 4, and then 2 and 2, right? But a square root looks for groups of 2, correct? So therefore, this guy stays out, he gets to come out, and he has to stay under, doesn't he? Right? You guys recall that? Make sense of that? Okay, well, same goes for cube roots and things like that. So therefore, if I had 32, the cube root of 32. So notice we got 4 and 8, which is 4 and 2. Well, I got a group of 2, but they can't come out. Can I break down the 4s? You can. 2 and 2, 2 and 2. Look, I got a group of 3 because I need a group of 3 now, correct? Does that make sense? Yes, no, maybe so. Okay. So that 2 gets to come out, but what about these yahoos? Where do they have to stay? They have to stay underneath, don't they? Okay? So it'd be a cube root of 4. As you've heard me in the past, I like to say that a radical is like a jail cell. Well, with a square root, you only need 2 people to get out. Well, if you get in a higher maximum prism, it's harder to get out like a cube root. You gotta have 3 people. An 8th root, what do you gotta have there? 8 people to get out, right? Does that make sense to everyone? 100th root, what are you looking for there? 100 people. Okay? You get what I'm trying to get at there, I think. Okay? Any questions on what I'm looking for there? Yes, ma'am. No problem. You want me to go back a page or right there?
Okay, I just forget.
Okay. Well, as you notice on the 6-2, we just don't do numbers, do we? What else is in there? We have some variables, correct? Right? Does everybody see that? So let's start easy. And let's start with, like, the square root of 4a cubed b squared c, like that. Let's just go with that. Okay? All right, ladies and gentlemen, here we go. So, what is the square root of 4? 2, right? That's simple enough. He gets to come outside. Because notice, obviously, 2 and 2, group of 2, gets to come out. What's 8 cubed?
8 times 8 times 8.
So there's 3 of them up there, right? So is there a group of 2 in there?
Yeah.
Is there one that has to stay under as well, right? And I'm going to show you something in just 1 second. So this is A, and 1 has to stay underneath, doesn't it? Okay, by the way, because this was A. Yeah, he's out, and that's why this guy's underneath, right? Does everybody see that? Understand that? We're okay with that. Okay, B squared. How many gets to come out? So we got B and B, so they get to come out, so the B gets to come out, right? And then you go under. Okay, and then notice C, he doesn't have a buddy, so he has to stay under, right? So our answer is 2AB square root of AC. Now, if you wrote this on the test, and this was worth, let's say, 4 points, I would give you 3 for that answer. That's not right. Can anybody tell me why? Well, I don't think you know because nobody's ever probably learned this yet. Okay. Just like I talked about beforehand, 36. Square root of 36. What's my answer there? 6. Why don't we ever write negative 6? Why don't we do that? Well, we're understanding that something squared, is going to be this number. But could it really been negative 6 too?
Yeah.
It could have really been, but I don't know why we never write both. Okay, when we're just taking a square root, because negative 6 is being negative 6 times negative 6, right? That's a group of 2. So why don't we write him as our answer? Well, I don't know why, but we don't. I'll be honest, I don't know why. I think it's called a simplified root or something like that. We just leave it to be that it's just square root of 36 is 6. Okay? But do we know what the value of A is right now? We don't. It could be positive or it could be negative, right? So what we do is, because we don't know what it is, anytime you have an even root and something comes out in odd power, Notice both of those guys come out odd powers, don't they? What's the power on them? Ones, right? You have to do an absolute value around those variables.
Why an absolute value?
Because then what does absolute value do? It makes them positive, right? So now, no matter what that value is, we will always have a positive answer coming out. Okay? So let me have you my little saying. Even root odd power, you need an absolute value. If you ever have an even root and an odd power comes out, you have to have, not parentheses, the absolute value around it to make it positive. Okay, that's the part that's pretty much you're going to sometimes forget. Hopefully you don't, but that's the thing that I've seen in the past that gets a piece of it. Okay? Even root, odd power. What about an odd root? Why don't we worry about him? Well, because the values could be negative, can't they? Remember, underneath odd roots, you could have negative numbers, so it's not a big deal. So that's why it's only on even roots and odd powers do we do absolute values. Why? Question here again. If I just had square root of a to the 4th, okay? I have 1, 2, 3, 4, right? There, he gets to come out, so does he, correct? So that comes out a squared. Why don't he was an even root, but now this is an even power. Why don't I have to do absolute value around even powers? Anybody have an idea? What is anything raised to an even power? Always positive, so the even power already takes care of it, always making it positive. Does that make sense? Sorry, Mom. Is that better? Okay, even roots, even powers, you don't have to because the even power already takes care of itself being a square. Okay? Make sense on that? Yes, no? Maybe so. Hooty yay. Now notice, I want somebody to tell me really quickly, what if I had the square root or the 4th root of a to the 101? How many of you guys want to write out 101 a's and group them by 4s? No? Can anybody tell me how many groups of 4 are in 101? How did you do that? You just went 101 divided by 4, right? And there's 25 in there with 1 left over. Well, so therefore, there is 25 groups of A that get to come out, right? But how many get to stay under? 1 gets to stay under. Was that an even root? 4th root? That's an even root, right? Did something come out odd power? So what do we have to do? Absolute value. Sorry, that's not a 9, by the way. Okay, so that's what it would be. So notice, let me show you another thing. Okay, let me go here. So I have, let's go the 5th root of a to the 16th, b to the 12th, c to the 15th. Okay? Can anybody tell me, using what Adam just did, instead of writing out 16 A's, 12 B's, and 15 C's, and then grouping them by 5s, what is a strategy that you can go ahead and figure this out? You divide it, don't you? Okay, how many times can 5 go into 16? 3 times, right? With how many left over? 1. Does that make sense? Because if I group that, I get 3 groups of 5 with 1 left over, right? Does everybody understand that process? How many times can 5 go into 12? Twice with 2 left over. Pretty simple, huh? How many times can 5 go into 15? 3 times. And notice because this was an odd root, do we even have to do absolute values? Nope, because they could be negative, couldn't they? Does that make sense? Pretty simple.
Wait, so why, what did you say, why these even have absolute value?
Because it was an odd root this time. And odd roots can come out negative, can't they? Okay. Scrolling down. So let's try this one more time. So I have 4, and I have a to the 9th, b to the 5th, and c cubed. Okay? Ooh, how many a's get to come out? 2 with 1 left over. Does everybody see that? Ms. Underwood, you okay? How many times can 4 go into 5? Once with 1 left over. Right? And then c cubed just stays under. None of them can come out, so he has to stay under. That was an even root. Who gets the absolute value? Just the b. Why? B's the one with the odd power. The squared already takes care of it becoming out to be something positive, because anything squared always comes out positive. But the b could have came out negative, so we put the absolute value around.
Wait, so if it was 5, say that 4 was a 5.
This right here?
Yeah,
Then no, I don't have to do absolute value on anything.
on anything, just when it's even.
Only even roots, odd power get to come out. Even root, odd power. Even root, odd power. Let's see what I can do. Now, okay, we're almost done, guys, really, to be honest with you. Okay, right now, what if I had this?
Distribute the.
Sorry for the interruption. Can we get all of the wrestlers going to the tournament down to the wrestling room now? Thank you.
Okay, say again, Tia.
Distribute the.
I can't bring an 18 through a plus sign. Okay, let me explain why to you really quick, okay? Because a lot of people want to do that. But give me 2 numbers, I don't really care. How about 2 and 3? That's a little bit better. And I go squared. Okay, so what you just want to do is you want to take that squared and take them into both, right? Which would that have been 4 plus 9, which is 13.
What, don't you have to times like that 18 times?
Yeah, I'm not going to do that, but this means, technically, order of operations says not to bring in the power yet. What does it tell us to do? Well, what is 2 plus 2? 5, and then 5 squared is 25. Is 13 and 25 the same?
No,
Which one's the true answer? 25. So you can't bring a squared through, and that just proves it to you, basically, right, that you can't do that. So what do we do? Well, that's still something, that's a power, isn't it? How many times can 6 go into 18? 3 times. X plus 3, 12, cubed. Even root odd power, though, so what do we know? Absolute value.
that's your answer?
Fairly simple, right? Anybody have any questions to that? Ladies and gentlemen, I think we're done. Let me just make sure. Oh. Okay. If you have your calculator, this is one time where having a TI calculator or a bigger scientific calculator is great. Let me hurry, just come down here. Let's say I had the 6th root of 400 and 12. Okay? We could break him down, and I could be exact. We can redo that. I'm going to do that because that's still important. What's in 412? At least, what do we know for sure? A 2 can go into it 206 times, right? What else can go into that? 2 and 103. 103 prime. 3 can't go. 4, 9, 7. Prime. So that would be, by the way, that would be a simplified answer. 6 root of 412. But sometimes we still, square roots we can kind of get away with, like square root of 2. We know that's in between 1 and 2, right? Because square root of 1 is 1, square root of 4 is 2, square root of 2 is in between there. Square root of 10, that's between 3 and 4, because square root of 9 is 3, square root of 4 is 16, so we know it's between 3 and 4. 6th root of 412, do you guys know your 6th roots, your raising powers of 6s very well? No. So let's show you how to do this. Does anybody know on this machine how to go ahead and do a 6th root of 412?
You do, that little button.
This one? First off, turn it on. So 412, what do I raise it to?
And then you push that, yeah, that one.
Caret.
Mm-hmm.
What am I
It's
gonna
not
raise it?
showing up though, a little bit.
Well, it's a caret. That's a caret, not a square root.
Oh, well, mine comes up, okay, let me push,
Huh?
that's what I do on mine.
As a radical?
Isn't it like this, Steve? Not what you're talking about?
Yeah, but that's this. Are this and this the same?
No.
No?
Wait, what are you trying to figure out then?
I'm trying to find the 6th root of 412.
Okay.
Okay? I can do it this way. Yes, sir.
What do you do 412 power of 6?
1/6. Remember how I just discussed earlier that 1/2 is the same thing as a square root. 1/3 is the same thing as a cube root. 1/4, 4th root, 1/5, 5th root, and so forth. Okay? So this is 1/6. I could go 1 divided by 6. 2.72 is the answer. Or another way I could do it is I put a 6 here, go to my math, see the one with this guy right here? That says, okay, that 6 that I put in is now going to go into at root. Does that make sense? So that's number 5. See how that 6 went into that x value? And then I go 412 as well. I can do that. Okay. Pretty simple, right? What would this guy look like though? What if I was looking like on your calculator you want to do the 6th root, let's say the 5th root of 215 squared. Well, I got 2 options. Okay, we're going to learn this next time. This is the same thing as 215 to the 2/5. Can anybody explain why the 2/5 comes about? Well, because this is a 5th root, right? So I could write this to be 215 squared to the 1/5. And what do we do on a power to a power? We multiply. What's 2 times 1/5? It's 2/5. Huh? So there's 2 options here. Let me show you what I could do. So one option, once again, is just like Miss Brianna just said, 215 caret, but I'm going to do what power? 2 divided by 5, okay, 8.56. Or I can do the 5th root, so 5 math, 5th root of 215 squared. So I got the same answer on both. Okay, any questions? Okay, what's the difference today? Biggest difference that you guys are going to maybe have to think about. When you have those even roots and something comes out odd power, you got to do that absolute value. That's the biggest thing you're going to check out with today, okay? All right, you already have your homework. Does anybody need an extra sheet that they maybe lost theirs or something? Okay, let's get working, please.